Hello, my name is Amos Tarfa. I'm a medical physicist based in Texas and a math and science curriculum writer. I've been writing math and science curriculum now for over 10 years. And in this video, I want to share with you the math remediation problem, the solution to the math remediation problem, how we can solve it. I've been studying the math remediation problem for about 12 years. I came upon the problem right after I finished teaching at a high school. So I've taught mathematics to middle schoolers, high schoolers, and college students. I've designed math programs for elementary school students as well. And so it's interesting because I've looked at the math spectrum from elementary, middle school, high school, college, and the PhD, like the whole spectrum, right? And what I realized is back in 2013, I wrote a book, 2013-2014, called Tools for Mastering Mathematics. This is a resource I can send to you for free to check out so you understand some of the ideas that I talk about. But what I realized was the more I study people like Isaac Newton, the more I study some of the greatest mathematicians who've ever lived, I noticed a pattern, right? They learn mathematics by mastery and not grade level. The idea of grade level mathematics is actually part of the problem. So there's a few reasons why students struggle with math. I think one of them is that we actually teach it on a grade level basis. That in and of itself is a problem. We can discuss that in another video in detail. But students, especially when they get to 5th grade and above, they should move based on mastery and themes on what they're learning. That leads me to the other problem in math education. And that is the problem of class titles. The very fact that a class called pre-algebra exists is a problem. Because what is pre-algebra, right? Pre-algebra is addition, subtraction, multiplication, division, and then you do algebra 1. But when should you do algebra 1? Well, you do it when you've mastered pre-algebra. Well, some states say you should do it in 8th grade. Some say in 9th grade. How about we just step back and say, you need to know how to add, subtract, multiply, and divide. You need to know fractions, decimals, percents, ratios, and proportions. When you've learned those things and have mastered those things, then you go into algebra 1. Now, what is algebra 2? That's another story. In America, you can live in the same state and just be 5 miles apart with somebody else, and your math curriculum can be very different. That person could be learning in algebra 2 equations. You could be learning in algebra 2 some other random topic. Some schools call it college algebra. The names are actually a problem. They're much bigger. Like, they're a bigger problem than we're willing to admit. Okay, so I know I'm going to dive into the solution for the remediation, but how did we even get to this point where we need so much remediation? Well, because number one, we don't have a comprehensive discussion framework for what we're talking about. And I'm not trying to tell us to start a program that presents math in a low bar. No, I want every student to do calculus independent of whatever they want to do with their lives. Why? Because calculus is beautiful. Just that it's beautiful. But if we want to get on the practical side, there are many reasons why they should learn calculus. But our current education system doesn't have a unified high bar for excellence for mathematics. That's part of what I'm trying to solve. So we're solving the K-12 math problem while solving the remediation problem at the same time because we need everybody everywhere to love math and to flourish in it. There's no time to fix one and wait for the other. We have to fix the whole thing. So we have the K-12 problem, which involves classes. Let me list another class, pre-calculus. What does that mean for somebody in Minnesota versus someone in Texas versus someone in California? It could mean a variety. Oh, there's honors pre-calc. There's pre-calc for this, for college credit. There's pre-calc for no college credit. Can we just take math topics, all the topics that need to be mastered? And again, we have to determine how far do we want students to go. For me, it's calculus 1. Statistics, data science, linear algebra. That's my base. That's the base level, right? And it's doable, right? There's no reason for summer breaks. And I know in this video I've dropped several intense things that we have to change, but we have to move. We have to move quickly. The times are upon us. If somebody does not know mathematics at this time in 2026, their options in their future are going to be very limited. Because AI is based on mathematics. Quantum computing is based on mathematics and physics. Space exploration, I'm not going to space, but space exploration is based on mathematics. Medical physics is based on mathematics. Even economics, I mean, I argue it's STEM. Some people say it's social. No, economics, again, is mathematics. Everything is mathematics. So we need a solution and we need to move fast. My recommendation, by the way, is that there's no summer break. This summer, 2026, there is no summer break for anybody because this is a state of emergency. Like, this is serious. We are living in very interesting times. And if we don't take it seriously, Like, some children are going to miss out on many opportunities. So that's why I keep moving back between the K-12 and the college. I've also taught in the K-12 and the college setting. So what I'm saying is, can we just be unified? Okay, so when somebody says, I am doing addition, okay, we know what they're working on. Or I'm working on graphing. Okay, great. Can we know what we're even talking about? That's one of the problems with, and I discuss some of that in my book, Tools for Mastering Mathematics. I also provide that comprehensive list in my book, Tools for Mastering Mathematics. So you can literally see a comprehensive list from counting to calculus in one sweep, and you can look at the names of some of the mathematicians behind all the concepts that we're teaching. So that is the first thing we need to solve. Before we solve the college remediation problem, we have to address the reason why it's there. And it's there because the system is so broken in mathematics education that the best thing to do is to actually start from scratch. We need to start from scratch, but we need to recognize that we cannot have a low bar. America has tried to have these standardized models for education, for math education, and one of them led to serious controversy. The Common Core, it led to some controversy. And I'm not going into that in this video, but my point is we need to recognize having a goal set is not the problem. The standard and the methods for that to be accomplished are some of the issues that happen. Singapore has a goal set. Singapore has a Federal Ministry of Education. In their mathematics implementation, they have standards and they're doing very well. Nigeria has standards, and for the schools that are functioning, they're doing okay, they're doing well. I'm not saying students love math in all the schools, but they're doing pretty well. America, I think we're all over the place and there are solutions, but there is no time to, there's just no time to waste, is what I'm trying to get at. So we need to solve these things and we need to go on overdrive quickly because our students are watching AI disrupt everything. And if AI is disrupting things in different industries, the question becomes, what are the tangible fundamental things that will remain? Mathematics is not going anywhere. Logic is not going anywhere. But if a student doesn't love math and struggles in math, well, what can they look to help them prepare for an uncertain future? So we need to fix the math education paradigm quickly. Okay, now let's talk about college remediation. So for the college remediation, the way I would look at it is I call it, there's a human approach to solving the math remediation problem. And the way we fix that is that we basically think of the traditional approach. Here's practice problems you need to work on. You need to do, there's these drills that you need to do. There's this practice, focus on all these gaps that we need to fix. But the problem, though, is some of the students that we're trying to help, they have an internal struggle. They're a little anxious, they're discouraged. Some of them feel like they're behind. Why am I doing Algebra 1 again and I'm in college? Many are convinced that they're simply not math people due to past failures. Stress and life circumstances contribute to the gap. It's not just about the math, right? So we are basically seeing that some of the students in the setting that they find themselves in, they're concerned, they have other issues beyond just the fact that they're not good at math. So how do we fix the remediation problem? I'm going to break that down in the next segment of this video. But in this first part, we've talked about the fact that we have problems. We don't have a unified language for understanding math education across states and across districts. Algebra 1 in one school might look quite different from Algebra 1 in another school. Pre-calculus in one school might look very different. Pre-calculus is offered as an honors course, is offered as dual enrollment, is offered as a non-honors, non-dual enrollment. There's too much going on. Let's bring it all together. Let's begin to navigate math excellence for America. This is my roadmap for math excellence for America and anybody else who wants to become very good in mathematics, like people like Isaac Newton and James Clerk Maxwell. Let's dive into that in the next part of this video. Thanks for watching this first part. Feel free to like, share, and subscribe. We'll pick it up in the second part on college remediation. Thank you for watching and have a blessed day.